People sometimes wonder how this can somehow manage to turn into this pure, clean drinking water. Some people may say that the recycling of sewage treatment water is wrong and that it'll never actually truly be clean enough for human consumption. Well, that's wrong. There's actually nothing to worry about because it's always been a process for so many years, and if it was a danger to human health, then it would have been ridden of a long, long time ago. Some people worry that the water we drink would be dangerous to human health because it could be considered recycled sewage or toilet water, when in reality it's much more. The sewage water goes through 4 different stages of cleaning, filtration, and disinfection, and these 4 stages are physical treatment. This is when large particles, such as stones, tree branches, facial tissues, socks, and much more, are trapped and ultimately removed by mesh screens, while dense, insoluble wastes sink to the bottom, considered to be called liquid grease, which includes oils, waxes, soaps, and to form a layer lighter than water at the top, and they are skimmed off, thus finishing the physical treatment. The next step to the 4-step purification process in wastewater is biological treatment. Bacteria are actually used in the wastewater treatment process to remove certain dissolved and suspended contaminants from the water. Nitrogen gas, or N2, is then bubbled out of the water into the atmosphere. This is 2 steps of nitrification and denitrification. Nitrification is when ammonia is converted into nitrite ions, or NO3 negative, while followed by the denitrifying bacteria converting nitrate ions into nitrogen. This is a reaction that requires to be oxidized. The 3rd step is filtration, the decomposition of organic substances, usually resulting in the production of inorganic salts. This has to be rid of. So, like this picture explains, reverse osmosis is used to do so. Osmosis alone is the process in which water moves across a semi-permeable membrane from an area of low solute concentration to high solute concentration. This requires no energy input, although reverse osmosis uses pressure to force the water in the opposite way. This does require an energy output, and it uses a membrane through which ions cannot travel. By doing this, liquid on one side of the membrane is completely pure, while on the other side of the membrane, the bad things are left behind. The final step to all of this is disinfection, in which the water is further disinfected before being released into the bodies of natural water. Chlorine is usually used for this, as well as ozone. And there you have it. The water is ready to drink, and it's actually cleaner than most tap water and most bottled water.